Okay, don't know what that was all about on the phone, but hey, good morning, everybody. I know it's late or early, depending on the circumstances. So, figured we'd pop in here real quick and do a quick video. I know it's going to take a little bit for everybody to pop in here, but today's task. All right, so I've tried multiple different normal BJT transistors for switching that I've used for quite some time. And well, I finally ran into a situation where what I had and what I typically use will not work for my application. So what I've done is I've sit down and went through countless different transistors, and a couple of them that were actually suggested I've actually tried in the circuit, and as far as at least here on the breadboard, and they won't function in the format that I need them to. So, thankfully I ordered about 10 different in-channel MOSFETs in order to go ahead and combat with what we're dealing with. So let's find the remote here. All right, so we're going to back out just a little bit. But yeah, today is not about amps. It kind of is, kind of isn't. Although I do have one over here that I'll be working on hopefully before the end of the night and get it taken care of as well. But the other one has been on order for quite some time, and well, with COVID and all the other good stuff that's been going around and on, it's been interesting. So anyhow, what I've done is I've sat down and drew out a really quick crude method over here on the paper. The only thing that I made a mistake on here is the 12 volts. We're actually going to use 5 volts as far as for the input voltage to activate our MOSFET and turn it on. So that's kind of important. Now, the MOSFETs have been out there for a long time, but they've really started getting popular as far as within the last 15-20 years, as far as into the industry with radio communications and everything. And a lot of it has to do with just some of the different characteristics that they have. So in this case, this one's actually designed as a voltage controlled small signal switch, which is what we need. We don't need a lot of current. That's part of the reason why it's in a TO92 package. It's very easy to work with as far as on the breadboard. It's also very easy in retrospect to using this for the application that I have. Now, there is other alternatives. Don't know that I have this one in the little transistor packs here. I've been ordering multiple different transistors with everything that we've been working on here lately. So, we've got some of our NPNs and our normal PNP. These are in what they call the TO23. Technically, it's a TO23-3. These are microscopic, and then you have to actually have a small proto board in order to go ahead and utilize it in this format. But we're not actually going to be using one of these for that. You go into the MOSFETs. I've even got some of the different MOSFETs that I'm actually starting to carry in these SOT packages, just to be able to go ahead and reference and work on some of the other stuff. Then we've got our dual op amps, multiple different variations of those, regulators. It's been really challenging because, I've got, several $1,000s worth of through-hole component parts on hand, but I don't have everything in relationship to the SMD and SMT technology. So that's one of the things that I've been working on the last couple of months, and just ordering basically another complete shop worth of parts that fits in just a few books. So that's kind of where we're at. Let's see here. Here. Go. We've got a few of them that likes to pop in here. A couple of them are from out of state. Of course, there's a few of them that are even further. For example, Australia. Chances are we'll have our buddy Wayne pop in here. Okay, so so that's what I've been doing the last couple of weeks. I've had oodles and gobs of parts to actually catalog and put in, so not a whole lot of work's actually been getting done. Okay, so let's just grab these other two here real quick. But it's actually kind of amazing when you stop and think about where things have been going. You know, this is a very large section, essentially, of my shop that's been able to be reduced down to book form. You know, there again, you know, you've got your different diodes for multiple different purposes, your xeniers, you know, going into that SMD stuff. So, so this is what I've been spending several weeks just trying to get all this stuff organized and put together. You know, voltage regulators, we already went through that. And then you go into a whole different thing, which is capacitors. You know, there's typically about 4 different sizes. So again, you know, and that has to do also with resistors, not just the capacitors. You know, some of these I actually went ahead and had to manually make all the labels for. After I did a couple of these, it was actually worth the extra time or extra money, actually, whenever I stopped and really started getting into it. Some of them I just ordered the sample books and got the normal for like the 402s, the 603s, the 805s. One of the things I don't have yet, they're on their way, is inductors. So, but anyways, besides being off on a tangent here, let me show you what I've actually come up with here. Grab one more little piece here. So one of the things that I'm going to go through here and work with, this is a very, very old tester, but you know, we've done some changing around. I've changed the leads out here just recently, mainly because the old vinyl just was so rough it just was impossible. Plus, using the little clips like this versus the alligator clips are going to make life a lot easier, especially for this application here, just for an example. So a couple of the variables that I've had to contend with, okay, is this load right here, which is going to be for on our input side. This is a variable that I cannot change because of how the radio attributes are. So this is what's actually held me in a position where I've not been able to get the circuit to function, but using a MOSFET versus BJT, it's actually possible. So This represents a 560 ohm point to ground, but this also goes high on voltage during the transmit section. So, the problem that I was having was the negative, or the grounding side, was pulling itself to ground through the circuit itself, because this did not go up high enough. It didn't go into an infinity state. So it allowed the relay, which I'm using in the radio, I'm using the same exact relay, but it was allowing this relay to go ahead and bypass the transmit, or the transistor essentially, and make its path to ground and go ahead and stay engaged. Now it was just enough to be able to hold it in, but not to release it. So unfortunately, this variable here is the reason why we've got the little circuit test set up. This one I've got set up with an LED just to make life a little easier, mainly because of the fact that we can actually see what's going on with it. But sometimes you have to go back and do things old school in order to come up with the right components for the circuit that you're working with. So I'll plug this little lead in here. So that is going to be for our input signal. And I'm actually going to connect that to the resistor substitution box. Okay, and turn this on. So we can get you guys a little bit wider zoom here. By the way, good evening or good afternoon there to you there, Wayne. I know you've been kind of wondering about me, and I've been wondering about me too. So, but anyhow, so let's see here. I got a little bench style multimeter here that I purchased here a few weeks ago too, because I thought maybe, at least until I can get everything finished up with the stream deck, it'll make things a little easier to kind of see on the workbench. So, all right, so I've actually got three. I shouldn't say three, but I've got a couple of different voltages going on the breadboard right now. I've got a 5 volt and a 12 volt that is coming off the main power supply. So it helps if I would put that actually on the ground here. So we'll go over here to the ground. So 14.5, pretty common as far as with what we use in radios that you're actually going to see. So, and then if we go over here to this rail here, we've got 5 volts. So the signal that I'm actually going to be using is a little closer to the 5 volts as far as that's going to be driving the transistor and turning it on. So, but I did want to show that we can do it either or based on what we've got going on. So let me grab another test lead here. I don't want to use that black one. Okay, so looking over here. We're going to set our resistance really high. All right, so right now I've got about so there's 110K. So there's a 100K right there on the resistance. So as we drop our resistance down and we're able to go ahead and start feeding the voltage, you'll actually start seeing the LED light up. All right, now I'm setting that. I've got this set up on the K reading, so we're going to see where our turn on point is, or where it just starts to turn on. Okay, so nothing even with 15K. So we're going to go back over here to regular ohms. Now we're at the 10K. We're going to start dropping. Eventually you'll see the LED. There we go. And that's at 1,000 ohms. I don't know if you guys can see that the LED is actually turned on now or not. So right there, that's actually not enough because we're not at the full current that we're actually able to pass through the transistor to turn on the LED to its full bright light. So, but when we drop down to 470, we've hit our threshold. So that's about as far down as what we need to go. Unfortunately, I don't have anything that goes between 1,000 and 470. So, but what I do have, which is going to be kind of unusual, as you're going to see here in just a minute. Which this is great as far as if you're also doing like varying on the LEDs themselves. If you want lights to actually brighten and dim, you can use the same circuit using the MOSFETs to do the same thing. So we'll get that out of the way. We're still on our 5 volts. Now remember, this is a 560. Now we can do one of two things. We can actually go ahead and introduce our 5 volts directly to that, because remember we've actually created a voltage divider. Since we're coming off of this, we've got 5 volts that we're feeding in, and then we're actually going directly to ground with 560. So let's see what we've got for voltage divider. Still showing. If we can get in here. Okay, so we're still showing 5 volts. And since I've already kind of played around with this circuit here, which didn't take me as long as I thought. Like I said, I tried one other one. That's the reason why part of this is still set up. But we're going to come off of here. And it's still best to go ahead and use a load resistor on the input. So since we know we've got 560 that's automatically going to ground no matter what in the circuit, we've got 560 there. So now let's see what we've got. Now we've got 2.7 volts, and we probably need closer to 3. I think is what the that's what the paper is requiring for this transistor. So we can actually come back over here. 4:30 in the afternoon. Awesome. Good evening, Dallas. Like I said, just doing some miscellaneous here. Like I said, we've got some printouts and going through here. On state green current. Okay, so all right, so full state on, or what we call RDS on, is actually at 4.5. So we're still not at our full turn on, and that's what we want to make sure that we can actually hit. So, but we've actually got a pretty decent current going on even at 2.7. So that one I believe was 560. So we're going to go down to about 330 ohm, and kind of see what we hit after that. I hadn't done much other than just making the circuit function. So, but we want to be able to pull the majority of that. This is actually 270 because it was easier to grab a hold of. So I'll turn these leads down a little bit. So I would like to get about 90. I would like to get about 97%. So we're at 3.4, 3.5 on our voltage. Max is 4.5, and that's at 270. So now whenever I increase this, because it's actually going to be at about 6.5 volts, the 270 should be just about ideal for that. This is also the reason why we want to go ahead and have what we've got, which is our input load resistor. Since we naturally need something to go ahead and drain off all the excess power once this lead goes dead, you know, this is actually important, very important. But this is, like I said, one of the factors that I cannot change in the circuit. So we have to work around that portion of it. So 3.5, so that's pretty good. We've got nearly full brightening on the LED. So that should work with our relay. And I tried to set this up. Unfortunately, the pins are so fine on the relay. I don't know whether or not I'm going to have any difficulty as far as doing that on here. But you know, my big thing is we can actually go ahead and go one step further. Okay, got a couple of leads. Okay, let's go ahead and hook this up to the 12-volt side. Kicks and grins. Okay, so now one of the things I'm going to do is I'm just going to use this resistor since there's nothing on this side of it. We're going to go right there. Okay. So it's all the way up. I may have to get a bigger turn pot for what I want to do. This is just a 1K that I grabbed, so we grabbed something that's about a 10K. Alright, so this is something that you guys typically don't get to see a whole lot of as far as here on the workbench, which is the prototyping. Alright, so Right there, we're at 0.8 volts, and it's still not actually turned on. So right there, we're at 2 volts. I don't know if you guys can see it lighting up. It's a little too high. .3, that's real close. 4.4, and that's pretty much at full volume here. So driving it any further than that really isn't going to help. But since we know what our fixed values have to be, if we wanted to, we can go ahead and pull this out. This is based on the 14.5 volts that's actually coming in. Yes, I know we're getting ready to shut down, so you gotta love these meters. All right, so let's just turn that off and then turn it back on. We don't die in the middle of what we're doing. But I picked this up, like I said, just to make life a little easier here in the videos. I'll stab myself. These are very, very thin probes that I've got on here right now. So check the one side, 1.2K and 8K. So the 1.2 would be an ideal resistor as far as for the circuit that we're working on, provided that what we're running into is the 12 volts, which there again, I know I'm not. I'm going to be much closer to the 5 volts that's going to be here. Like I said, I think it's 6.5 as far as on the circuit. So, you know, I'll have to make some small adjustments and drop the resistance down, because we're not looking for current on this point. The only thing we're looking for is voltage. So, but makes life nice. Like I said, I've tried 2 or 3 different ones this evening, and this is the perfect setup for the relay. So I'm going to try. I don't know if I can do that or not. I might just have to build the circuit all over again. Okay. So we'll take that out. Go ahead and leave that in. Since this is a 12-volt relay, yes, Charles, I am alive, buddy. Good evening time. All right, so that in. We'll move this over. Okay. Still got everything else connected, so there we go. That's the circuit that we're actually trying to make right there. Even with as low as what we've got it, it's still enough to go ahead and drive the relay. And the relay, the way I've got it set up, just so that you may or may not hear the clicking whenever I do that, but that's the reason why I want put the LED in there, so that you could actually see that it lights up just by engaging and disengaging, you know, using our finger as a switch essentially. Yes, I did choose pink for a reason. We may have a young lady that pops in here, so that's the reason why I chose the two colors, one of which I know she loves blue, and pink for being something off the wall different. So which means that we are going to be set to go ahead and make the same circuit, install it into our radio, and get it taken care of. So that's what we got, guys. Alrighty. Well, hopefully this may help somebody else out as far as that's trying to come across something, and you wind up with a situation where you can figure out how to make it work. Well, this is what breadboards are for. Sadly, I had to replace my old breadboard and wait for the last week. I had too many sections that were just in too bad a shape, where it's been plugged in and unplugged for, geez, like 15 years. So I ordered this one off of Amazon, which is kind of nice. It does come with a different binding posts so that you can have your common ground that would actually go over to one of your rails, and the ability to go ahead and use 3 different voltage applications as far as on the input for multiple different hookups based on what you're trying to do. The simpler way to do it now, with all the different kits and what have you to build, they actually make these little boards here, which are great for your secondary voltages for 3 and 5 volts. So there's a lot more circuits that they're using lower and lower voltages in order to go ahead and work the different applications, even though we still use 12 and 14 volts for a lot of the applications that we work with. So, like I said, it's kind of nice. That's 5 volts. You can actually take, move our little jumper over, which makes that 3 volts. And at 3 volts, it will not energize the transistor, which is awesome. So we know we need at least 5 volts in order to go ahead and create the circuit, which we've got available to us. All right, guys, well, just that easy. Of course, you just gotta keep building one circuit at a time. I know a lot of people have looked at breadboards and all this other stuff, and they get confused. One of the biggest pieces of advice anytime you're building something like this that I would recommend is honestly just sit down and remember, you take it one wire at a time, one circuit at a time. You can actually get through almost anything that is needing build. All right, guys. Well, I'm going to go ahead and build this circuit, get it in the radio. Hopefully we'll be able to get that done this evening so that I can call the customer and get it off this week and in his hands. And we've got, like I said, another amplifier coming up. As soon as I get that done, then we get to start in on another box of fun. I'm not sure how many are actually in the circuit itself or in the box. I'm thinking there's about 6 of them. And like I said, we're still working on stuff from February, March of last year. I've been putting off and been telling everybody that, give me another month or so. And right now, I think we're going to just wait off until this fall as far as to take anything else in, just because I want to make sure that I can get everything caught up. And I've got a lot of other things as far as around the house that need to be taken care of. So I'm not going to be able to spend a whole lot of time out here, but I will be trying to come in here at least once, hopefully here fairly quick. I'll be able to come in here at least once a week and get you guys set up on a video. Once we get everybody else taken care of and get the ball rolling better, we'll try to shoot a few more videos a week instead of just one a month, which is what it appears that it's been here lately. So, all right, guys, take care. God bless. We'll catch you on that next live feed.